Howdy folks, welcome back. So now that we have our foundation for angles and different types of measures, let's focus on one of the major applications for this, which is going to get into trigonometric functions. So for this first section on that, we're going to look at just the unit circle, which is one way that we can analyze the trig functions. So we're going to see other ways in subsequent videos, but for now we're just going to focus on the unit circle. So how do we set this all up? Well, let's first consider angles formed within a unit circle, which is a circle with radius 1, with vertex at the origin and initial side determined by the positive x-axis. So just like we've had from the start. By correlating the length of the tangent line at the point 1, 0 and wrapped around the circle to the point of intersection, we can develop functions based on the coordinates of intersection. What? Well, again, a picture is going to illuminate a lot. So let's first get our coordinates system. And so now let's draw a unit circle. So let's say something like this. Not perfect, but again, we want all of these to be ones. So -1, -1. So we know all of those coordinates. One away from the center of the circle. Now, they want us to draw a tangent line. So remember, a tangent line hits the circle at one point, and that point is 1, 0. So they want us to hit over here. So we'd have to draw a vertical line through here. Now, if we had a segment of length 1, we can make this a number line if we wanted to. Something like this. But now, how do they get their angles? Well, if I were to pick a point on this circle, it's going to correspond to a specific length. So again, I'm kind of like wrapping this number line around the circle. I'm curling it around the circle. And that's how I'm getting my angle. So, this particular length is going to correspond to a point here of xy. So that's going to give me this angle here. So I have an angle based off of this length of an arc, based off of this number line that's curling around that circle. It's a little confusing, I know. But the big thing is that it's a real number. So you're looking at an angle as a real number, not a degree measure or something like that. So that's kind of the relationship. You have to just think of that number line curling around to wherever you want it. So if I had an angle over here, then obviously more of that number line is going to curl around to get to this point over here, on the circle. So it's just going to vary from angle to angle, but that angle is a real number. So if that's kind of the situation we got going on, we can define the 6 trigonometric functions in the following way. So let t be the real number. So again, somewhere on this number line, that's on the tangent. And let xy be the point on the unit circle corresponding to t, so just like we showed up above. So the sine of that angle, of that real number, is going to be just the y coordinate. Nice, right? The cosine of the angle is going to be x. So just the first value in your ordered pair. So those two are really nice for any angle defined on a unit circle. It's just x is the cosine, y is the sine. Cut and dry. From those two things, we can get these other 4 trig functions. So the tangent is going to be y over x, and we can't have the denominator equal to 0. You've got the cosecant of your angle, which is going to be the reciprocal of our sine function. You have the secant, which is the reciprocal of our cosine function, and then the cotangent, which is the reciprocal of our tangent function. So again, these two are the real heart and soul of our angle. If we know those, we know all the other ones. So very important. So let's just focus on those sines and cosines. So looking at a couple of diagrams here, so we have some special angles here. So we got 90 degrees. So 90 degrees, if I wanted to know the sine and cosine, all I have to do is look at that ordered pair. So the cosine of 90 should be equal to the x value, and the x value is 0. The sine of 90 should be the y value, which is 1. So very, very nice when you have a unit circle. And we could do that for 180, we could do that for 270, any of those angles. So something a little more diverse like this. You can see we're splitting that 90 degrees in half. So we're talking about multiples of 45 through here. So we could get, again, our sines and cosines. X is the cosine, y is the sine. So no matter where it is on that unit circle, you can always find it. And then you can go even further and look at multiples of 30 and to get all those different sines and cosines. As long as it's the unit circle, that's the important piece. If it's not the unit circle, then we got to do something else. And we'll see how to do that in later sections. So, but that's the idea with the unit circle. X's and Y's gives us cosines and sines. So, how can we maybe try to remember some of this without using a calculator? Well, as it turns out, there is an easy way to remember these trig values if you can memorize them for the first quadrant. So the first quadrant is really the most important because the other quadrants are going to kind of be mirror images of those values, but the signs will change, the positives and negatives. So, but let's first take a look at the pattern. So if we had the sine of 0 based on our previous diagrams, it should be equal to 0. But we can write it this way to help us see the pattern. So the sine of 0 degrees is going to be the square root of 0 over 2, sine of 30, square root of 1 over 2, sine of 45, square root of 2 over 2, sine of 60, square root of 3 over 2, and then sine of 90, square root of 4 over 2, which is equal to 1, which is equal to 0. So very, very nice. So you can see the sines will increase in size as you go from 0 to 90, and just the opposite for the cosines. So the cosine of 0 is square root of 4 over 2, which is 1, square root of 3 over 2, square root of 2 over 2, square root of 1 over 2, and square root of 0 over 2, which is 0. So very, very nice pattern and little practice to be able to figure those out. Ideally, you'd like to remember those and memorize those, but if you can't, it's not the end of the world. You can always fall back on your calculator as much as you shouldn't need to. Okay, so that's just the first quadrant. Everything is positive in the first quadrant, but what happens in the other quadrants? The other quadrants have different positives and negatives associated with it, different signs, not the same sign, of sine and cosine as follows. So sine and cosine is positive in the first, sine is positive in the second, but the cosine is negative. Why? Well, think about the value of x's and y's. If you're in the second quadrant, the y values are still positive because you're above the x-axis. The cosines are negative though because now you're on the negative side of the x-axis. So you can see that these would all be negative numbers over on this side. So that's why cosine is negative. In the third quadrant, both the x's and y's are negative, so the sines and cosines are both negative. And then the fourth quadrant, again, x is positive, but y is negative because you're in the fourth quadrant. So again, if you can memorize this part of it, that'll help you with the sines and cosines and the actual SIGN of those values. So let's put that into practice. Let's try couple problems, and then we'll see where we end up. Determine whether each of the following expressions is positive or negative without using a calculator. Oh no. All right, well, so we want the sine of 121 degrees. So the million-dollar question is, what quadrant is 121 degrees going to fall in? So, well, we know 0 to 90 degrees is quadrant 1, 90 to 180 is quadrant 2. So this should be quadrant 2. And if it's in quadrant 2, what do we know about the y values? Sine is talking about the y values. So this should be positive. Cosine of 359 degrees. What quadrant is 359 in? Well, we should know that's in quadrant 4, right? Quadrant 4. So what are the x values in quadrant 4? Because now we're talking about cosine. Those are positive as well. Nothing too interesting yet, huh? All right, what about our last one? Sine of 7 pi over 6. Ew, radians. Well, we can do a couple of things. We can try to put it into the quadrant by changing it to its degree measure, and then we're good to go. But can we do it without doing that? Sure. Remember, 180 degrees is pi radians. So how does this compare to pi radians? Is it bigger than pi? Is it smaller than pi? Well, you should see that this is bigger than pi. Pi would be 6 pi over 6, so 7 pi over 6 is definitely bigger, so that pushes it into the third quadrant. But could it be in the fourth quadrant? Well, then it'd have to be greater than 3 pi over 2. Straight down is 3 pi over 2. And now, it's not, because we can find common denominators and show that it's bigger. So we know that this should be in quadrant 3. And since it's in quadrant 3 and we're talking about sine, we should know both sine and cosine is negative. Okay. Now, in a lot of textbooks, they will give you a unit circle and give you a lot of detail to it. And I kind of gave a snippet from our own textbook from the second to the last page. So you can see it's got all of these special angles in degrees. It's got the special angles in radians all the way around this whole circle. And then it's also got the ordered pairs for those special angles as well. So again, you can immediately read the sine and cosine from that unit circle if you have this diagram. So very, very useful tool. So, and again, no calculators should be necessary. If you have this, or you can memorize this, then you're in really good shape. And that's what you'd like to do. So, all right, well, let's stop there and we'll pick up some of these examples in the next video. See you soon.